Alright, let's continue where we left off. So previously we have talked about major trigonometric identities, right? So from now on, we're going to have a look at the major trigonometric functions. We'll start by looking at the sine function. Again, when you look at a new type of function, always pay attention to its graph. So the curved green line here, it's a graph of sine function. And also note that these are the main properties of the sine function. First of all, its domain is the whole real number set. There's no limitations for the input x here. And secondly, the range of this function is between -1 and +1. So basically, the function will oscillate between -1 and +1. And its amplitude is 1. The amplitude is farthest distance the oscillator deviates from its equilibrium position. And maximum value is 1, minimum value is -1. And also we know 2 pi is its minimum positive period. It has a y-intercept 0, 0, and many x-intercepts, right? All the x-intercepts can be denoted as k pi 0, where k belongs to an integer set. And this function is an odd function because for any x belongs to the domain, we always have sine -x equals -sine x. So the graph of this function has point symmetry in the origin point. And also we can express all its increasing intervals in this way. So basically you can find one of the increasing intervals, which is from -half pi to +half pi, and then plus 2k pi. So any increasing interval can be expressed in this way. And also, in order to express this decreasing interval, again, we can find one of the decreasing interval, for example, from half pi to 3 pi over 2, then plus 2k pi for both the lower bound and upper bound. Then all of the decreasing intervals can be expressed in this way, okay? Again, most important thing is you must be familiar with its graph. Any questions? No? Alright, then the graph of cosine functions is illustrated in the purple line here. So basically it has similar shape with the sine function except a phase shift. So the main properties of cosine functions is similar to the ones to the sine function. First of all, the domain is the whole real number set. Range is between -1 and +1. Maximum value equals 1. Minimum value is -1. So basically it oscillates between -1 and +1. And again, its amplitude equals 1, which is this distance here. This is its amplitude. And again, 2 pi is its minimum positive period. Cosine x is also a periodic function. And the y-intercept is 0, 1, which is this point here. And there are infinite number of x-intercepts, which can all be expressed in 2 pi plus k pi, where k belongs to an integer set. And the function is an even function because for any x belongs to the domain, we always have cosine -x equals cosine x. We have already talked about this trigonometric identity previously, right? And all the increasing intervals can be expressed as -pi plus 2k pi to 2k pi. Again, you can find one of the increasing intervals like this, which is from -pi to 0, then plus 2k pi to both ends. Then all of the increasing intervals can be expressed in this. And similarly, all decreasing intervals can be expressed as 2k pi to pi plus 2k pi. Clear? Alright, next, also note that because cosine can be expressed as sine x plus half pi, right? According to what we have learned for the trigonometric identities. And therefore, we know according to function transformation theory, sine x and cosine x are actually interchangeable by a horizontal translation. So this parameter is actually your d. So d equals -half pi, right? If d equals -half pi, that means based on the graph of the function y equals sine x, the graph of cosine x can be obtained by transforming the sine x to the left by half pi units, right? So, which means based on the green curve, if you translate the green curve to the left by half pi units, then you will get the graph of sine x plus a half pi, which is actually cosine x, which is a curve highlighted in purple, right? Did you get it? Alright, next, the tangent function. The graph of the tangent function is illustrated on the right side. So note that the domain is not the whole real number set, but the whole real number set except these points. At these points, the function is simply not defined, because in that case, you will have a denominator 0. The range of this function, though, is from negative infinity to positive infinity. Again, tangent function is also a periodic function, but its minimum positive period is pi, not 2 pi. Also, have a look at its y-intercept, which is 0, 0, this point here. And there are infinite number of x-intercepts, which can all be expressed in this way, k pi 0, where k belongs to integer set. Well, for any x belongs to the domain, we always have tangent negative x equals negative tangent x. So we know tangent x is an odd function, which has point symmetry in the origin point. Again, make sure you're able to express all its increasing intervals. So in each period, the function is simply an increasing function. And all the vertical symptoms can also be expressed as x equals a half pi plus k pi, where k belongs to the integer set. Alright, next, the cosecant function. Cosecant function is actually the reciprocal of sine, right? So we could obtain its graph by analyzing the reciprocal of the graph of sine. So note that on the diagram on the right, the dotted green line is sine x, right? So you can use the property of sine x to analyze the graph of cosecant x. Therefore, the behavior or graph of cosecant x can be studied by analyzing the behavior of sine x. So as you can see here, well, for example, let's consider one of the period here. When x is between 0 and half pi, if you consider this branch here, sine x is the increasing function, right? And correspondingly, cosecant x will decrease from positive infinity all the way to this point, which is 1, right? And therefore, you can use similar methods to analyze the other branches along the x-axis of the graph of cosecant x. And note that these are the main properties of cosecant function. So first of all, the domain is the whole real number set except at these points. X cannot be k pi, where k belongs to the integer set, because at these points the denominator will be 0. The function is not defined. The range of that function is from negative infinity to negative 1, union with 1 to positive infinity, which means these two ranges, right? These two intervals. And this is also a periodic function. The minimum positive period is 2 pi. Vertical symptoms can be expressed as x equals k pi. So basically these lines are the vertical symptoms of cosecant x. Also, we can express this increasing intervals in this way and decreasing intervals in this way. Alright, similarly, next, let's have a look at the graph of secant function. So secant x is the reciprocal of cosine, right? So first of all, we can draw the graph of cosine, and the behavior of secant x can be studied by analyzing the behavior of cosine x. So as you can see here, the highlighted purple line here is the graph of secant x. And the main properties of secant function are as follows. Make sure you're able to understand each of them, okay? Alright, next function is the cotangent function, whose graph looks like the one on the right side. Main properties of cotangent function is as follows. First, the domain of this function is a real number set, except at these points, k pi, where k belongs to the integer set. For example, the function cannot be this at these locations. At these locations, function is simply not defined, right? And cotangent function is also a periodic function. The minimum positive period is pi, and there are infinite number of so there are infinite number of x-intercepts, and there are no y-intercepts. And cotangent function is also an odd function because we can have cotangent negative x equals negative cotangent x for all x belongs to the domain. There's no increasing intervals, but we can express all the decreasing intervals like this: k pi to pi plus k pi. So which means basically memorize this behavior on one of the intervals first, then expand this by add k pi to both ends. All the vertical asymptotes can be expressed as x equals k pi, where k belongs to an integer set. Right, next, let's have a look at an example to check your understanding. Can you show that the graph of y equals cotangent x can be obtained by reflecting the graph of y equals tangent x in the y-axis and then horizontally translating it to the right by half of pi units? Alright, so because cotangent x can be expressed as tangent half pi minus x, right? And tangent half pi minus x is actually tangent negative x minus half pi, right? So according to function transformation theory, so basically we added two parameters here. So this parameter corresponds to your k. There are four parameters a, k, b, and c, right? So k equals negative 1 here. And the second parameter d equals half pi. So remember, if your base function is tangent x, then this new function can be obtained by transforming tangent x, right? If k is negative 1, that means we need to reflect the original function tangent x in the y-axis, then followed by the transformation corresponds to d, which means translating horizontally to the right by half of pi units. Then you can get the graph of cotangent x, which is actually tangent negative x minus half pi, from the original function tangent x, right? Also, tangent x and cotangent x are interchangeable. You get it? Alright, next let's have a look at transformations of sine and cosine functions. Okay, remember the function transformation theory tells us that if you add four parameters a, k, b, c like this, the graph of the new function can be obtained by transforming the original function, right? This also applies to both sine and cosine. And actually, in sine and cosine functions, the four parameters has a special meaning. For example, if you add a parameter a here, that corresponds to vertical stretch on compression, and if a is less than 0, also reflecting the x-axis, right? So specifically for sine or cosine, the absolute value of a is their amplitudes. So because that's the maximum deviation, maximum distance that the oscillator deviates from its equilibrium position, right? So just remember the absolute value of a is its amplitude. And if you add another parameter k, k corresponds to a horizontal stretch or compression. And if k is less than 0, a reflection in the y-axis, right? And also, because k corresponds to a horizontal compression or stretch, it must have something to do with its period. So if you stretch it horizontally, that extends its period, right? Otherwise, if you compress the graph in the horizontal direction, then you will compress its period as well, right? So k has something to do with its period, and specifically the period of sine or cosine equals 2 pi over the absolute value of k. So note that that's the minimum positive period, which equals 2 pi over the absolute value of k. We can prove this actually, but I'm not going to show you here. Just remember that because of the time constraints, I'm not going to show it here for you, and if you are interested, you can just tell me after this class, okay? I'll explain this to you, why this is true. So just remember here, the period equals 2 pi over the absolute value of k. And the next parameter, d, corresponds to horizontal translation. And in sine and cosine function, d has a special name, which is called phase shift. Last parameter is the easiest one. It corresponds to vertical translation up or down, depending on whether c is positive or negative. Are you clear? Okay, let's have a look at a example to check your understanding. So, a cosine function has a maximum value of 1, a minimum value of -5, a phase shift of a quarter pi to the right, and a period of a half pi. There are two questions. First, write an equation for the function. Then sketch the graph of the function over at least one cycle. Are you able to solve both of them? So note that the first question only asks you to write an equation. You don't have to write all of the possible equations. Alright, let's have a look at the solution together. So first of all, we know that's a sine function, right? And what we don't know is the 4 parameters. Because for a sine function, there could be 4 parameters, a, k, b, and c, right? So first of all, we could let the function, or let the desired function be y equals a times cosine of k times x minus d, then plus c. And next, we need to determine the 4 parameters, right? According to the given information. Okay, first of all, it gives you maximum value equals 5, minimum value equals -5. So that means we can calculate this amplitude, right? Amplitude equals a half of the maximum minus the minimum. And we know the maximum of that function equals 1. Minimum value of that function is -5, right? Therefore, we know its amplitude is a half of 1 plus 5, which gives us 3. Therefore, we know the absolute value of a equals 3. So, in order for simplicity, you could let a be positive 3. Of course, you could also let a be negative 3, but it's not necessary. We prefer positive values for simplicity reasons. So we can just let a equals positive 3. Then you can have the first parameter a, right? And then k has something to do with its period. Period is a half pi. So period equals a half pi. And on the other hand, we know period equals 2 pi over the absolute value of k. Okay, by default, by default, the period means a minimum positive period. Okay, so this gives us the absolute value of k equals 4. Again, for simplicity reasons, we can just let k equals positive 4. That solves the second parameter, right? Phase shift is a quarter pi, so we can directly write d equals quarter pi to the right, so d equals positive a quarter pi, right? That gives the third parameter. And last, c. C is the vertical shift or up or down. That's actually the equilibrium position of the function. It always equals a half of the minimum plus the maximum. So in this case, that's a half of -5 plus 1, right? And that gives us -2. So C equals -2. And therefore we know the desired function is y equals 3 times cosine of 4 times x minus d, which is a quarter pi, then minus c. That's a function of the desired function, an expression of the desired function, right? Any questions? Alright, that completes the first question. We have found an equation for the function, right? For the second question, sketch the graph of the function over at least one cycle. Of course, we can sketch the graph of the function by transforming the original function of y equals cosine x, right? But is there any way we can quickly sketch a function like this? Alright, actually there is another quicker way we can sketch the graph of a function like this. So note that no matter what your function is, as long as this function is sine or cosine, basically it has a overall shape like this, right? You get it? So first of all, we can draw a curve like this. And then let's determine its equilibrium position, maximum, minimum position, and then find the relative position of the y-axis and x-axis. Then we can sketch the graph of a function like this. Okay, first of all, we know the maximum value of that function is here, which is positive 1, right? Minimum value is here, which is -5. And the equilibrium position is a half of the maximum and the minimum, so that's -2 here, right? Then we should be able to find the position of the x-axis. It's somewhere between 1 and -2 and closer to 1. So we can draw the x-axis here. Right? And then next we need to determine where the y-axis is. Note that we can try to find some anchor point to help us to find the relative position of y. So for example, if x equals quarter pi, then we know cosine 4 times 0 is 1. So that gives us y equals 1, which is a maximum point. So we know that this peak corresponds to a x, which equals a quarter pi, right? Then y-axis is somewhere to the left of this point. So we should find another anchor point to the left of that point. So for example, you can find this point here because we know the distance between this point is a period, right? And we also know the period of this function is a half pi, right? So distance between these adjacent two peaks is a half pi. Therefore, we can easily find the x coordinate of this point, which is a quarter pi minus a half pi, which is negative a quarter pi, right? You see that? And we also know the lowest point here has equal distance between the two adjacent peaks. So the x coordinate of this point must be 0. You have a 0 here. So that's actually your y-axis, right? So y-axis is here. You follow me? And actually, this is one of the periods from a quarter pi to positive a quarter pi. Then usually we'll also need to mark this key point and this key point, because this point here to negative a quarter pi is a quarter of the period. So that's negative a quarter pi plus a quarter of the period, which gives us negative an eighth pi here, right? And of course this point here is 0 plus a quarter period, which equals positive an eighth pi, right? And usually you will label this point, this point, this point, this point, this point along one of the periods. And this is a sketch of this function. You get it? Also label the maximum point it can get here, 1. Minimum point here is -5, and equilibrium station, which is -2 here. So that's the sketch of such a function. You get it? Alright, if you don't have any questions, let's have a look at another example. Can you model the graph shown using a sine function? So basically this problem is actually similar to the previous one, except all the information are given to you via a graph, not a statement using plain English language, right? So from this graph we can also observe the maximum is here, the minimum is here, and the equilibrium station is somewhere here. So that's just the 1/2 of the maximum plus the minimum. So from this given information we know first the maximum equals 2, minimum equals -4, then amplitude equals 1/2 of maximum minus minimum. So the amplitude is 3. We can let A equals 3, right? And then the period is, well, if you count it from here, then this is the length of the period, minimum positive period. It's the distance between two adjacent lowest points. And we know the distance here is pi. So the minimum positive period is pi, right? And that also equals 2 pi over k. So we know the absolute value of k equals 2. And we can simply let k equals positive 2. About the phase shift, we can consider a problem like this. If there's no phase shift, then the first peak would occur at x equals a quarter of the period, which equals a quarter pi. But now the first peak occurs at x equals here, a 1/2 pi. So that means there must be a phase shift, which is a 1/2 pi minus a quarter pi, which is a quarter pi to the right. So we know d equals a quarter pi. And last parameter c is the vertical translation, which is a middle point between maximum and minimum. That's a 1/2 of maximum plus minimum, which is -1. And therefore we can decide all the 4 parameters. So the desired equation is y equals 3 times sine of 2x minus a quarter pi minus 1. You get it? Basically the method should be the same with the previous example.